Good afternoon and welcome to the second semiconductor session. I think Narendra did a great job in translating everything into the language which everybody understands. I think hats off to him. So let me just start with this question. You hear about this Indian semiconductor mission. Government is giving incentives to set up manufacturing in India. I hope all of you have all keeping up with the news, right? Why are we doing this? Why are we giving incentives to make manufacturing or manufacture semiconductors in India? Any idea? Why should we do that? So see, semiconductors right now is pretty much the basis for everything you do. When we talk of AI, we talk of the softwares which run everywhere, the SaaS or this, all the fancy things or the good things. I wouldn't call them fancy. They're good things, and that's where the world is moving. The basis of everything is semiconductors, GPUs to run the latest LLMs and so on. So I think it was heartening to hear what happened in the previous panel. And we have with us, to talk about the fabrication. I think let me just start with, on the fabrication side, from Professor Manoj, who's been closely associated with India's only semiconductor factory. I'm using factory, not fab, so as to make it little more, the lingo more common for all of us. So where are we with that, and where are things going with that, and how far are we from the latest technology or catching up on that?
Thank you. As the member of the Management Council of India's only semiconductor laboratory, SCL, and also its Finance Committee Chairman, some things that I can reveal. I know a lot more things are ongoing. As we know, apart from catering to the strategic sector, that is to defense and space, right now the SCL, which is a 190 nanometer facility, is currently expediting its progress towards modernizing itself. Maybe you have already heard that Government of India had already invited expression of interest and had proposed an amount of 10,000 crore rupees for modernizing it. That is for the factory. Of course, we can always say it is currently on a legacy node. For advanced nodes, there is already a India semiconductor policy that was announced in December 2021, covering all the 4 different segments, that is for the semiconductor chip, display fab, compound semiconductor, and as well as the DLI scheme for the design linked incentive scheme. As a result of which, we already know the announcements that have already come, with Micron having decided to set up first ATMP facility in Dholera, and many other players that are currently in discussion. So I personally believe that our semiconductor journey has actually intensified very significantly after 2021 semiconductor policy announcements. And in order to make it more attractive, there was more changes that were proposed middle way to make the incentives much more attractive, and as a result of which we are getting interest from many players. As Prime Minister Modi ji always says, yahi samay hai, sahi samay hai. That is, that in India's semiconductor dream of ever-growing consumption, whether it is across the consumer electronic markets that we see, whether mobile phones or for computers, every single thing we do today, as you highlighted. If we look at, I represent Gati Shakti Vishwavidyalaya, which is India's first university in the transportation sector. If we look in the transportation sector, every single thing we are doing today, whether introduction of new indigenous trains like Vande Bharat, that have significant number of electronics and semiconductor component. Automotive, India is becoming an automotive hub. We all know that around 40% of automotive cost today is electronics and semiconductor. Irrespective of the space that we look at today, and tomorrow when we, for example, modernize our warehouses, we bring a smart factory 4.0 situations everywhere, in the telecom sector with the 5G deployment, and now moving forward to the 6G world, there is a semiconductor content that is now getting more and more common and more useful. In the overall context of things, just to summarize very quickly, we have made a lot of progress after years and years of talking and little action. I think after December 21, there is a significant action on the ground, and there is a need now to identify an ecosystem where we move from local design local need to local design to local development to local deployment. And India is both a market as well as India is a large design house with the facilities that we are currently going to set up, starting with the first micron facility and moving ahead. I believe that India is in the right stage, and we will see many more announcements from the government as we go ahead. Thank you.
Good to know, some of the consumption is going to happen through some of the things that we use every day, trains. I mean, trains are not going to be what we are, people who have traveled more than 20 years ago, used to be basically 4 wheels and gets you from one place to another. I think consumers of today are demanding facilities at a different level altogether, right? And from trains to cars to aeroplanes, I think they're all going to use chips. Let me just ask you a question. When we say, when we talk about science or technology, when we refer to very difficult technology, what do we normally say? Rocket science, right? That is now looks like we have conquered good part of it, right? What is the next? What are the other difficult technologies when we say, okay, if you're not a rocket scientist, I will say, I do this. How does that compare to rocket science? What is the other thing? Neurosurgery? Yeah, I'm a neurosurgeon. Sounds pretty impressive, right? If I say that. Guys, semiconductor design comes pretty much in that category, The modern day semiconductor design, we are talking nanometers. Difficult to imagine what nanometer is. It's easier to say, very difficult to imagine forget nanometers, even microns are very difficult to imagine. So anyway, coming to that, talking about the semiconductors and how things are going to be shaping up India's future. I think we have wealth of experience here with other speakers here. So Dr. Sunil, I'll go to you to talk about, where do you see things going from your perspective in terms of technology, the adoption, who's going to be the user of our technology, and all the wonderful things that we heard from the previous panel. So.
Yeah, sure, thank you. See, what I would say is that there will be a rapid evolution in the demand for semiconductors in India in all sectors. And let's take just 2 examples. If you have heard of this company called Dixon, it's a contract manufacturer. They make everything from home appliances all the way to phones. Recently I read, I don't know how far it is true, but their market cap is more than Foxconn. I mean, market cap is not necessarily the only measure of success, but anyway. Now, if this company has to become competitive with respect to China or even with respect to Taiwan, then the only way they can do it is smart backward integration. And smart backward integration means that just like you custom design the appliance, you have to custom design the chips. So that's one example. The other example I'll give you from my parent company, which is Reliance. They have developed their own equipment for 5G telecom. Now, they too, if they want to deploy this in large volumes, okay, what in today's term is called population scale, then the scale is so large that it will definitely benefit from having our own chips designed and manufactured. Going forward, there is a lot of demand that will be generated for 6G because there are a lot of things which you need to do in 6G which you don't have to do for 5G. One thing, for example, is that the frequency at which 6G operates is so high that it's almost line of sight communication. So if you don't want to have too many, base stations, then you will need something called reconfigurable intelligent surfaces. And that's an entirely new domain. You need to design the equipment, but you also need to design custom chips to make that happen. So this is how so basically what I'm saying is that in every domain, there is an opportunity to do backward integration and become more competitive vis-a-vis China and Taiwan. More importantly, perhaps, is the kind of R&D that is going on in institutes. In semiconductors, the 2 top institutes are IIT Bombay and IISc. And they have been developing chips which actually can create markets. And often creation of a market gives you far more returns than just feeding into an existing market. Apple phones are one prime example of that. So I'll just give you two or three examples before I close. One, in I know about IIT Bombay more than others, so I'll quote from there. So there is one chip that they have designed which is a one-time programmable memory, and it is used for secure applications of all kinds. The second example is a neuromorphic chip which can be used for AI and which is extremely low power because it uses what is called spiked neural networks and therefore can make AI available on mobile devices. The third example is a chip which is a magnetic field sensor. It can detect magnetic fields at picotesla level. And there are large number of applications of this technology. One of them being figuring out through remote sensing corrosion in pipelines. But there are so many other examples. So what I'm saying is that all this research that is going on will open up the possibilities of entirely new markets. And that is something we are extremely good at. In India, there is a market and there are such people who will create new markets. And so we are the future.
To you, Dr. Atre, we want to share some of your experiences based on what you do at IISc, how things are shaping up, where do you see some of the new work happening, and where do you see the demand for those products, and where do you see the markets going up in terms of usage, and where we have the capability also. We all know some of the standard products that are being done. So where do you see India's position there?
Thanks. The way I look at it is, and I've been with semiconductor industry for almost 25, 30 years, the way I look at it is there is going to be a huge demand for all types of semiconductors, whether you call it highly complex, cutting edge technology nodes or some of the other older nodes. I don't think we need to distinguish between one or the other. It is not necessary that we only should look at 3 nanometers, 7 nanometers. I think even things like 90 nanometers or even older make a lot of contribution, number one. Number two, from India's perspective and looking at the future demand and growth, I think sensors are going to play a very, very important role. And sensors, from my perspective, first of all, they're important because they cut across domains. Whether it is healthcare, whether it is avionics, whether it is robotics, anything, you need sensors, number one. Number two, if you look at all types, what are the 5 sensors we have? Touch, taste, etc. So we have sensors for all of them. And integrating multifaceted sensors is also going to become very important. Number 3, things like context-aware sensing. Depending upon what the situation is in that particular system, to switch over to the relevant type of sensing is also going to become very important. So the way I look at it, sensors are going to be the key, whether it is low power in terms of variables or IoTs, or it may be even high power in terms of space or defense. Sensors are going to be very important. They will play a role because many, many startups can contribute in that area, depending upon what is their domain of expertise. So the way I look at it, there are a lot of problems to be solved, and to sort of stress on what Dr. Sherlekar said, we should look at what existing technologies we have today and then see where they can be applied as very, very interesting and unique solutions for the problems.
Wonderful. How many people know what is sensor here? He made it very simple, like we have 5 sensors in the body, right? What are sensors? Sensors are basically the electronic version of our senses. When we talk of devices, measuring temperature, automatic temperature sensor, that's basically an electronic device that will tell the temperature of a room. pressure measurement, viscosity measurement. You know, these are all the different sensors that we can use that helps us in automation. The word Internet of Things is actually the basis of that is sensor. So once you know the value of a particular dimension that you're trying to measure or any parameter you're trying to measure, that's where the sensor comes into play. So this forms the basis for all the automation that's going to take place, whether in our domestic use or in the industrial use. So talking of that, that's a perfect segue into our next panelist here, who's actually working towards, you know, creating one application which is centered around sensors. You know, we all talk about big chips, we all know about processors in our CPU, in our laptops and servers and how powerful our machines are, but not everybody needs a Ferrari, right? You need a lot of other cars also on the road, even city driving. And that's where you need some specific applications, you know, for doing a particular task, you need smaller specific chips. So that's where our next speaker comes into an entrepreneurial journey, creating that particular chip from India. So over to you to talk about what you are doing and how is it important for, or who is this important for, right? I think what you're doing, who cares about it, I think, as Narendra was saying, right?
Sure, absolutely. Thank you, Sanjeev. Yeah, so building on what Madhu had said, we are basically focusing on sensor applications for automotive applications, right? And why automotive? If you see today, there are three factors that are increasing the count of electronics inside a vehicle. By the way, before I go forward, I would like to ask the audience a question, and you can just guess about it. Do you know what percentage of the cost of your vehicle is electronics? Can anyone take a guess? Very close. Yeah. So it's approximately 30 to 40%, and it's going to be 50% by the turn of this decade. So that's how heavily interdependent, you know, vehicles or automotive is on electronics today, right? So it's a big playing field. And in this, you know, like I said, one factor, the three factors, one is a move towards electrification. Then you have increasing connectivity where the vehicle talks to the cloud, the vehicle talks with other vehicles, and you have automation. So this is where the role of sensors come into play, where because of automation, because the car needs to make decisions on the road, it needs to rely on the data that the sensors are giving to it, right? And we are addressing a very interesting application within this, which is basically the tire health monitoring, right? And all of us know how critical tires are. They are the singular point of contact with the road, isn't it? And so we are making India's first tire monitoring ASIC, and we are doing this in collaboration with a large automotive tier 1 right here in India. And recently we signed an MOU with them, and we are delivering chips to them starting 2025, right? So this is, again, to one of your points which you made, who wants it, right? And why is this important? And we are seeing, because, you know, for a semiconductor ecosystem to thrive, what I feel there are three key things. One is, of course, policies, in which the government plays a big role, and it has been playing a big role. We are one of the beneficiaries of it in terms of the chips to startup from the government of India, from MIT. And you also have, you know, centers of excellence, like for example, Sanjeev leads the Nasscom COE IoT, and similarly we have a COE for fabless startups called Safal, and we are part of that. And I think the policies should continue to support these things so that, you know, more and more startups can foster in this ecosystem. Then second thing is, of course, customers, right? Unless and until you have demand, who are you creating for, really? And we have been fortunate enough to find that customer very early on in our journey. And thanks to that, we have a very clear roadmap for the next couple of years. And the third thing is the manufacturing ability. And Raghu from Keynes spoke a great deal on that about OSATs coming, and that's a great thing. And we have also seen Micron, who is now investing in India, and they are going to set up a packaging plant. Talking about packaging, we have heard so much about design, about simulations, about running on FPGA, but there's so much more beyond that to get a real silicon working, right? And that is what we are dealing with right now. There are very few OSATs who actually deal with complex packaging. So in our application, we require, so it's a multi-chip module. What is meant by multi-chip module is that inside that IC, right, that plastic covering that you see, there are multiple components inside. And so,
but why do you need such a complexity to measure pressure of a tire and report that, right?
That's a very good question.
I'm a little confused on that.
Sure, absolutely. So basically, these sensing are done by something called as MEMS, micro electromechanical systems, which have their own fabrication technologies. They are usually different from the silicon that we design. The silicon that we design actually takes the signal that is coming from these sensors, by the way, which are in microvolts to very tens of millivolts. So highly, very, very small signals, highly laden with noise. So we have to do signal processing that has to remove the noise and take it forward. And then we also have a communication protocol. We are also integrating, the first company to integrate Bluetooth Low Energy on this chip. So yeah, coming back to the packaging complexity, there are very few OSATs who can deal this complexity, and even lesser who want to work with startups like us.
So great. So people can then, now we can look forward. Even some of the smaller cars will be able. We don't have to go out and look our pressure, right?
Exactly.
I need to get this for to get air in my tires. So this will automatically come on my screen. It already comes in some high-end cars.
Absolutely.
I think it will become very common going forward,
Absolutely.
right?
And there are a lot of applications. I think with automation now, you would be able to measure your tire wear. You'd be able to predict road conditions, load conditions. So there's a lot that you can do with the sensing
But he made a very good point, during his when he was talking. We talk about how much electronics is there in the car. We have not come to self-driven cars yet. Once we come to that, I don't know what is the percentage that's going to be. Then it will be like, what is not electronics in a car is something that we'll talk about. We hear about Apple making a car, right? We hear about Google making a car, but do you hear about General Motors making iPhone? We don't, right? We only hear computer makers started making car because car is becoming all electronics and software. That is the reason behind it. So guys, I mean, world is becoming more electronic and semiconductor. Of course, mechanical will be there. It's not that mechanics has to be there for everything, but they are all going to be controlled and monitored using sensors, processed by analytics through semiconductors, and the end result will be all automation and of course wherever human intervention needed. So before I go to the next round, I mean, any questions from the audience? From the interesting points that were discussed, we have been on the semiconductor topic in the previous panel and this. So we have some experts sitting here. I'd like to hear what audience thinks about this. Yeah, please.
Talking of manufacturing, right? Yeah. So of course we are going to do it for the first time. Of course, SCL has been there, so I should really say first time. But if you are talking of like 28 nanometer or something, it's for the first time. We will have to be competitive. There's no choice. Quality will have to be tops. There's no choice, because if it isn't, the company will go bankrupt. Okay. So the way it will happen is we will first license the technology. Okay. So it will be a running technology which you license, you set up your fab, and after that it's your job to make sure that it remains competitive by continuously increasing the yield. And that increase in yield is possible only if you can collect enough amount of data to figure out how to tune your process. And it's a virtuous cycle, because the more the output, the more data you get, and the more your yield. And the more your yield, the more you are competitive, therefore the more your output. Okay?
Any other? Yeah. Go ahead.
A lot of chips will be manufactured. I'm thinking of the after this, a lot of garbage of chips will be also sorry. After a lot of chips will be manufactured, then lot of garbage of chips will also be manufactured. Will be there. So the policy should be made in advance and before it becomes a problem. So like how it can be recycled or reused. Some apparel industry could be set up for this. I was thinking any government is thinking or industry is thinking in this direction.
So if I were to answer your question in a generic manner, even on the net zero or sustainability targets that United Nations gave, India is committed to be the first one or to be able to achieve that much before the 2030 deadline. So India definitely is much serious about the environment if that was the consideration point that you were mentioning. The second point that I want to add here is that few things have happened which is radically different, right? First is we were not known to be risk takers as in Indians, but today you look at the number of startups, we already crossed 1 lakh, we are big risk takers. Secondly, we have learned to deal with failures. If Chandrayaan 3 is a great success story, let us remember that Chandrayaan 2, there was a minor last minute failure, but what did happen? Prime Minister himself went and consoled the then ISRO chief and announced the Chandrayaan 3 date. So we have quickly moved on. Thirdly, semiconductor manufacturing is all about an ecosystem. When my co-panelist mentioned chip to startup scheme, one thing, big thing that government announced was 85,000 additional skilled manpower for the sector. That is a big ecosystem development in terms of the manpower to develop. So I have one request to make as an educational institute. Semiconductor is a capital intensive business, we all know, and training such people at 85,000, such a large scale will require strong participation support from industry in terms of making design kits, tool kits available, making academic licenses available. We cannot have teachers just like that. We request many of the industry experts to come and possibly take part of the courses so that our students that we want to train can actually be trained with the relevant skills. So these 2 or 3 requests I also want to make on behalf of the government and also on behalf of the academic institutions. Thank you.
All right. So if there are no more questions, I can have a, okay.
Yeah, I had one last question. There has been quite some discussion on custom semiconductors, right? So we know, I mean, coming from the semiconductor industry, we know that semiconductor industry is all about scale, right? And scale comes when you're actually manufacturing in large volumes. I'm not talking about the process node, right? I'm actually talking about the chip itself, right? So if you're talking about custom semiconductors, I mean, will the economies of scale be justified for the market, which is there in India, is my question. We wanted to understand at a market level, at a macro level. Thanks.
I can kind of address.
Let's paraphrase the question also.
Yeah.
It was a little convoluted for most of us.
I mean, what we are doing is also a kind of a custom, application. Even though the silicon that we are designing can be used in multiple applications, in automotive as well as industrial applications, like if you think of it. So we primarily measure 3 parameters: the pressure, temperature, and acceleration. So there are multiple use cases, right? You can think of smart bands. You can think of the the HVAC inside the car. You can think of the air pressure inside the engine manifold. However, now the IC that we are making, that is custom to a certain application, and that is the tire monitoring. And why? Because it has been built in a way which is very power conservative, right? So tire monitoring is basically an application which is battery powered, and it's not at all performance demanding, unlike processors and high-speed processors. So you have to custom build that particular silicon for an application which is tire monitoring. And of course, I kind of agree with your point that volumes do matter, and that is where you need to have a leading customer who kind of can promise you that they will buy from you certain millions of chips. At which point your investment that you're putting in, because it's quite a capital intensive field, you need to build your own packaging tools, you need to build your test solutions. So it should be kind of feasible, make financial feasibility, the demand versus your
given
investment.
interest of time, I think yes. So I think that's the purpose of doing it in Make in India. The cost of these things come down. We can do more of custom silicon. You don't have to think that I have to invest tens of millions of dollars before I make a chip. So the more we do Make in India, more in-house design here, lower is the cost of chip and higher is going to be the usage. It's as simple as that. So with that, I'll want a closing remark from you, Professor Manoj, Dr. Sunil, Dr. Atre, and you. So let's start quickly, 30 seconds, less than 30 seconds actually.
So in this journey, I think bigger ecosystem, as I mentioned, has already been created in the form of government support, in the form of big companies willing and declaring their express intent and having signed MOUs, and within signing of MOUs, within 1 month getting the land papers and everything. So there is a Gati and the Shakti both in the government's intent.
With an aspirational population that we have, which is continuously getting more and more prosperous, there is an exploding market for everything in India, and everything uses semiconductors. Therefore, there is an exploding market for semiconductors, and there is an exploding number of talented people who can serve this market. And that has been made very clear from what is happening in all the institutes in the country. And finally, there is enormous amount of talent available to develop disruptive technologies which will create new markets, and those technologies will become startups, and those startups will address not only the exploding Indian market at population scale, but the world market, and make a lot of money. And this is a virtuous circle.
I've been involved in many meetings, discussions, forums, right from the government side to the industry to academia. And my one submission is, please don't get hung up on the latest technology node. That is a wrong approach. There are tons of things India needs on the lower technology nodes, which can happen and which should be enabled. And I think the startup ecosystem would be really, really beneficial in this entire cycle. So please do not think that only the smallest technology node is where success lies. Success lies in a lot of other technology nodes too.
So I'll just make it very short, that the time is definitely now. So I would encourage all entrepreneurs who are thinking of doing something in semiconductor, please come and step forward and do it. Thanks.
So I think we had a chance to hear a lot of views here. I think with the closing remark that, semiconductor is as strategic as any other initiative. If there's any learning to be done from the space program, be at it, never leave it. Slow and steady will keep on winning the race. You don't always have to be number one in everything, but you will get there if you keep at it, right? And we don't have to say that we have to do 2 nanometer, 1 nanometer, or whatever. 1 nanometer is not there, but anyway. So these type of things are these type of things don't matter. And I think we are on a right track. A lot of good things happening both in our institutes and in our industry, as well as with the startups. So with that note, thank you all of you for being here, and thank you for the patience the audience has shown. Thank you, Narendra, who's been guiding this initiative from the day one, and he's been ardent, passionate about that India has to do this in semiconductor. It doesn't happen with that kind of. I have not seen that kind of a passion with anybody else, and that's what got me also involved. So thank you, Narendra, and big hand for the speakers and Narendra here, who's been.